let's just imagine for a moment, okay? Let's imagine we've been through a paper, okay? This was question 1. We did it. This was the answer all of us wrote. And then we've got our 5 minutes at the end, and we come back to this, and then some of you think, okay, wait, something has gone wrong. We want to fix this. What should we do? Can someone give me some advice? Yeah, Laura.
Maybe, wait, I don't know if this is right, but like, you know how when you get a 15, you have to times 5 times x and 2x times 3?
Okay, alright, so the first part that we notice is an issue, right, is you can see in the first line, the denominator here has changed. Yes, it was 3 and 5 before. It's 15 now. It should be 15, by the way. Why 15? 15 is a good number.
3 times 5.
It's the
Highest common. No, lowest common.
it's the lowest common multiple, right? I can fit 3's into this number, and I can fit 5's into this number, so that'll give me a common denominator. That's good, okay? But if the denominator changes, then what are these things at the top called again? The numerators also must change, okay? So for this x on 3 to become not x on 3 but something on 15, what have I multiplied that fraction by? I multiplied the top and bottom by 5. So this is going to become 5x. In much the same way, to turn this guy into something on 15, what did I multiply by? 3. So 2x becomes 6x. Okay, so now we've identified the problem. That's just as hard as doing a problem, right? Identifying what's wrong. Say it again.
That's why I'm confused.
Okay, so I'm not finished yet, yeah? All I've done so far is I've converted these two fractions into different forms, not simple forms, but forms that can talk to each other, yeah? Now they're both going to be on 15. Yes, that's right. So these two are equal to 7. I'm now going to carry on with Gary's working, but just correct it a little bit. So these numbers should be 5 and 6, shouldn't they? You see where they've come from? 5 and 6. Okay, now I know the numbers aren't quite right. We'll fix them in a second. But just carrying on his working, what's Gary done from this line to this line? What's he done?
Is that a 7 there? I have the top line and then
Oh no, come on.
Come on, we can work this one out. I should point out.
That is a 7.
I should point this line itself is actually doing two things. It's doing this, and then it's doing this. Right? So let's take them one step at a time. That top thing, the thing I circled, what did he do? We can all work this out.
Is it not? He's grouping the x's.
Okay,
together.
good. So he had x and 2x, right?
Yeah.
So they became 3x.
And then he's also.
And then where'd this number come from? He's multiplied through by 15, hasn't he? Because I don't want 15 on the denominator. I want to get it out of the way. And we have to multiply by 15 too. We have 15 there as well. Okay? He multiplied across by 15. That gave him 105. And then what are these about? Why did you do this?
To get rid of the 3.
Very good. Okay, so now we know what he did. Let's do it with the right numbers. This shouldn't be 3. It should actually be 11. Right? Is that 105 correct?
Yes.
It is, right? Because it's still 7 times 15. Thumbs up. But now instead of dividing by 3, I divide by 11 because that's the number I'm trying to get rid of. Okay? So it looks to me like I don't think that's going to be anything nice, is
You
it?
get 9.5454.
Yeah, I'm just going to leave it there. Okay? I suppose I could, if I wanted to, I could write that as 9 and 6 elevenths. Okay? But I don't think either of those is... It's not like I told you, please give me a mixed numeral or an improper fraction. They're both fine. Okay? Can we have a look at this one? What do you think? Happy? Not happy?
It seems.
I understood it. I'll try the answer.
It looks vaguely correct. Okay, let's step through it one step at a time. This is algebra, right? There's numbers and then there's pronumerals, so I'm going to deal with them one at a time. 12 and 18. What's turned them into 2 and 3? I've divided both by 6. This is actually what I did here, but in reverse. Yeah, here I had nice simple numbers, but I wanted to make them bigger, so these could work together. But here I have big numbers and I want to make them smaller. So we divided through by 6. 12 divided by 6 is 2. 18 divided by 6 is 3. Thumbs up. Now what?
Yes.
It looks right. Okay. Having dealt with the numbers, I want to deal with the pronumerals now. I'm just going to go through in order. I've conveniently given them to you in matching order. So you say x cubed. That's actually an abbreviation. What's an abbreviation for?
X by x by x.
X times x times x 3 times. That's why there's a 3 there. right? So if there's x times x up here and a single x down the bottom, then one pair will cancel, right? Which leaves you with 2x's at the top. Cool. So x squared, that's x times x. You can keep on going through. You can see there's 2 a's up here, a times a, and there's 5 of them there. So when you do your cancelling, you get on the bottom 3 left. And up here, does this check out?
Yes.
Thumbs up. Okay, so that looks good. How many significant figures? How did you know there were 4? How did you know there were 4? Because there's just 4. Okay. There are 3 zeros, right? These guys, and they don't count. They're not significant. Why aren't they significant? Whereas this guy, you are telling me, is.
He's surrounded by around.
Okay, so these numbers here, right? These could have come from approximating, right? Like I did some count and then someone told me round to the nearest 1,000. So that's where the zeros came from. But this number cannot come from rounding, right? This is not on the end of the number. It's right there nestled in the middle. So it must have come by me actually counting up. I was at 7, what is this? This is 8 million and something. So I was at 7,999,000, da da da. And then I ticked over and got to 8 million, etc. And I kept on counting, right? So all of these numbers are significant because I counted them or measured them in some way. Whereas those could have been approximated.